Function composition. So we have some super fun notation here. Recall f, this is not circle, this is f composed with g of x is the same as f of g of x. So it's very important you know how to read it. This is f composed with g, it's an operation. The input is x, this does not mean multiplication. Again, we can rewrite this as f of, remember anytime we open a set of parentheses we say of g of x. That means that's the input. So let's do some examples. Consider the functions f of x equals 2x squared minus 5x and g of x equals 4x plus 5. So we're going to find f composed with g of x, and we're going to rewrite it as f of g of x. Okay, so this is f of 4x plus 5 because that's what g of x was. And you may know exactly how to do this. Some of you may know exactly what to plug in. But if you don't, and this is hard for you, we're going to do some scratch on the side. So we are going to just plug in some values for f of x because that's what I'm plugging into, right? I'm replacing every x in here with something here. So let's plug in a few just so you can sort of get the feel for this. So f of 1, and we're not going to simplify because we're just sort of trying to identify the pattern. So this will be f of 1, well that's 2 times 1 squared minus 5 times 1. We've replaced every x with 1. Okay, so what about f of 7? Well that's 2 times 7 squared minus 5 times 7. And I should have actually highlighted these x's as well, right? I'm replacing every x with a 7. So this x, this x has been replaced with 7. So we need to replace this x and this x as well with 7. Okay, again, we're not going to clean it up. We are just trying to find the pattern. What's f of negative 5? Well, now we've replaced x with negative 5. So this x will be replaced with negative 5, and so will this one. So 2 times negative 5 squared minus 5 times negative 5. Hopefully you're starting to see this, but we're going to keep doing this until, maybe it's a little bit uncomfortable for you, but until you start actually turning your brain off and sort of doing it on autopilot. Okay, so I'm just going to keep doing this over and over and over again. So f of 9, well, that's 2 times 9 squared minus 5 times 9. So what about like f of 100? F of 100 is 2 times 100 squared minus 5 times 100. Okay, and you're going to keep doing it until you start to hear your voice and you go, ugh, and you can kind of tell that it's become boring. So f of 17 is 2 times 17 squared minus 5 times 17. And when you start to hear that in your voice, I usually hear it in my students' voices, I know I've gone far enough, that means that they've gotten the pattern, your brain has switched from direct thinking about it to actively thinking about it, working it out, to autopilot. So f of 206, well that's 2 times 206 squared minus 5 times 206. Okay, we're going to keep going. So let's do 2 more. What's f of 33? Well, that's 2 times 33 squared minus 5 times 33. And just when you've lulled yourself into complacency, I'm going to throw in f of 4x plus 5. So what do I do to my input? Well, I square it and multiply by 2. And then 5 times the input. And I subtract that off, right? So you can do this over and over and over again. This is just scratch, so you see the pattern. And like I said, if I hear my students do it, I make them say it out loud. I can hear the point where things turn to autopilot. When you turn to autopilot, that's when you're good. So you're just going to plug in the one we need. So this is 2 times the input minus 5, input squared rather, minus 5 times the input. Does that make sense? you're just doing all of these. This is just to see the pattern. This has nothing to do with the problem until we get to the last step. You're just recognizing the pattern, the process. Now we start cleaning it up. Well, you may be tempted to distribute this too. Do not do it. We have to do order of operations. The first thing we do is work inside the parentheses and clean it up. Well, 4x plus 5 cannot be simplified any further. Okay. Then the next thing we do is we address that power, right? And if you already know the form to write this, to square it easily, write it down. Do not just square the front and square the back. You have to have a third piece. So if you're not sure, you just write it side by side and you're going to FOIL it. Okay, so I'm just writing this again just so I can see what we're doing. And I'm going to go ahead and leave the 2 out here. Let's go ahead and FOIL this. So we get 2 times, well, we get 16x squared. 4 times 5 is 20, so we get 20x plus another 20x because we get 5 times 4x plus 25 minus. And let's go ahead and distribute this. That's minus, what, 20x minus 25? So now we're going to distribute this. But it might be helpful, instead of writing plus 20x, to write that as 40x. So 2 times 16x squared, well, that's 32x squared, plus, well, now I'm going to do 2 times 40x, that's 80x, plus 2 times 25, that's 50, minus 20x minus 25. All I did here was recopy this. I distributed the negative, and now I'm just rewriting that. So now we combine like terms. I have 32x squared. I have an 80x and a minus 20x. So looks like that's plus 60x. And then I have 50 minus 25. That's plus 25. Okay, if you want to find the domain of this one is not very exciting, but I'll tell you so when you do more complicated ones, you know what to do. You're going to check 2 places. You're always going to check the domain of the inside, domain of the inner function, which in our example was 4x plus 5. We know the domain of that is all real numbers. There are no domain restrictions because there's no fractions, there's no even roots, right? And then you check the domain of the final answer. Of the final simplified answer, which in our case was 32x squared plus 60x plus 25. Well, that also has domain all real numbers. So the domain of our composition, this guy right here, is all real numbers. We'll get to some that are more exciting, and then it'll be more fun to do. Okay, so let's do g composed with f of x. Now, when we do this one, we're going to do the same process, but we're going to start off with the functions in the other order. So let me just remind you, f of x was 2x squared minus 5x, and g of x is 4x plus 5. That way I can scroll down. Okay, so I want g composed with f of x. I always read it as g composed with f, and the input is x. This is g of f of x, which means I am now replacing everything inside of g, this x right here, with f of x. So instead of f of x, I'm going to write 2x squared minus 5x. All this stuff, right? That goes right here. So I've replaced this x right here with 2x squared minus 5x. So I'm also going to replace this x right here with that. Okay. So again, if you need to, you can do some scratch. If you see it, you go for it. But if not, let's do some scratch. So what's g of 0? Well, g of 0 is 4 times 0 plus 5. Replacing this input in place of that x. So what's g of 19? Well, that's 4 times 19 plus 5. What's g of 103? Well, that's 4 times 103 plus 5. What's g of 15.4? Well, that's 4 times 15.4 plus 5. What's g of 87? Well, that's 4 times 87 plus 5. So what is g of 2x squared minus 5x? Well, that's 4 times 2x squared minus 5x plus 5. And I snuck it in there, right? So it kind of lulls you into complacency. You just plug it in numbers. You can do that all day long. And then I slipped in one when you were sort of on autopilot. And then you were able to do it. So that's going to be our strategy. So g of 2x squared minus 5x is this. So that is 4 times 2x squared minus 5x plus 5. Let's look at it carefully. So I've replaced x with 2x squared minus 5x. So I replace this x right here with 2x squared minus 5x. 4 times x plus 5. 4 times the new x plus 5. And then we clean it up, right? We distribute. So this is what? 8x squared minus 20x plus 5. And that is g composed with f of x. And then to find the domain, we check two places. We check the inside of the composition. 2x squared minus 5x, we see that has domain all real numbers. There are no fractions, there are no even roots, so we're not throwing anything away. And then we check the final simplified answer, 8x squared minus 20x plus 5. Again, that has no domain restrictions. So we say that g composed with f of x has domain all real numbers.